Hi everyone. In this session, I am going to discuss about the solutions for the previous JEE mains questions asked from the units and dimension chapter. This is basically the first chapter and which is quite easy. If a student is being comfortable with the dimensions as well as the units of a physical quantity, then these questions from this chapter can be answered them very easily. You can see the first question which has been asked in the 2019. He says that expression for the time he's asking to find out in terms of G, universal gravitational constant, H, Planck's constant, C, speed of light. So therefore now we have to express a time in terms of this G, H and C. But before that way, basically what we require is we require the dimensional formulas. So now let us write down, work out the dimensional formulas of each and the three physical quantities, which are called as H, C and even G. First I am going for G now. From Newton's law of gravitation, we know that it is F is equals to, it is G into m1 into m2 by r square. Let us write down the formula for subject 2 of G. G is equals to F into r square divided by m square. Using the dimensions of force, it is m1 L1 t power minus 2 into r is L divided by mass is also m. So therefore, on simplifying, 1 minus 2 will become m to the power of minus 1, a to the power of 1 plus 2 will become 3, and t to the power of minus 2. So therefore, this is the dimensional formula of gravitational constant. Next is H Planck's constant. So for the Planck's constant dimension formula, basic formula we'll use, that is energy of a photon is given by E is equals to h nu. So therefore H is equals to, it is E by, H is equals to E by nu. H is energy, therefore m1 L2 t power minus 2, that is actually force into displacement. Force formula we have used, multiplied by displacement gives you energy. And energy is energy by frequency. Frequency is reciprocal of time, t power minus 1. On simplifying, we'll get m1 L2 t power minus 1. Similar speed of light, speed is m0 L1 t power minus 2. After getting the time, getting this one, let us assume the dimensional formula for time will be equal to g to the power of a dimensions and h to the power of b dimensions and even c to the power of c. C is speed of light and c is here constant. Now dimensionally t can be written as m0 L0 t to the power of 1. We can write on the left hand side. If we see on the right hand side, g can be replaced by m to the power of minus 1 L cube and t to the power of minus 2 whole to the power of a. Similarly, h will be replaced by m to the power of 1 L to the power of 2 and t to the power of minus 1 whole to the power of b. C is speed of light, it is L1 t power minus 1 whole to the power of c. Now if we simplify on the right hand side, m to the power of minus a plus b we are going to get, right, using the first law of indices, and L to the power of 3a plus 2b plus c, and t to the power of, it is minus 2a minus b minus c. On the left hand side, as we know, it is m0 L0 t power minus 1. Let us compare the equal powers. So therefore power m0, m to the power of 0, m to the power of, therefore both must be equal now. So therefore to get back the dimensionally the given equation correct. So therefore minus a plus b will be equal to 0, which means it is a is equals to b. Okay. If we compare the powers of L, it is 3a plus 2b plus c will be equal to 0. Even a and b are equal now. Let us put b also equal to a. Therefore this equation can be written as 3a plus 2a will become 5a plus c will be equal to 0. Similarly, third one, it is minus 2a regarding equating the time or equating the powers of time. 2a minus b minus c will be equal to minus 1. These two are equal. Therefore, I'll get minus 3a, b also will become a, minus c will be equal to minus 1. On adding, 5a minus 3a will become 2a is equals to 2a will be equal to minus 1. 2a will be equal to y minus 1. Minus, it should be plus 1 time, no? Because t to the power of plus 1 we have to express plus 1. So therefore a will be equal to, it is 1 by 2. If a is 1 by 2, b also will be equal to 1 by 2. If B also will be equal to 1 by 2, next is C we have to find out. Let us take the help of the second equation or even third equation. If I am using the second equation, 3A, 3 by 2, A is 1 by 2, plus 2B, B also 2 by 2, plus C will be equal to 0. 2 is 1, 3 by 2 plus 1 will be equal to 5 by 2. Therefore, C will be equal to minus of 5 by 2. So for the G to the power of half, G to the power of half and H to the power of half, G and H should be the numerator. Okay, and C to the power of minus 5. So minus 5 to the power of half and C will be going down. Therefore, power C is 5. C is 5. Therefore, option is C is correct. Let's move on to the next problem. Okay, this problem, which is given in the 2019, is based on the conversion from one system to another system. Unit of density is given as 128 kg per meter cube in certain units. Okay, the length will be taken as 25 centimeters and the mass will be taken as 50 grams. The numerical value of density we have to find out. Since for conversion always we'll use N1 U1 is equals to N2 U2. N1 is 128 and 128 in units will be kg per meter cube. Okay. On the right hand side, N2 value we have to find out, but density will be expressed in mass by volume, no? Density by given by the formula mass by volume, mass by volume. So therefore, volume can be now replaced by L cube. Volume can be replaced by L cube. Therefore, volume density will be replaced by mass is M divided by L cube. Okay, mass will be measured in 50 grams and length will be measured in 25 centimeters. Accordingly, mass will be measured as 50 grams. 1 gram is equals to 10 to the power of minus 3 kg, because kg will get cancelled. Divided by length is 25 centimeters. 25 into 10 to the power of minus, because centimeters has been converted into meters. 25 into 10 to the power of minus 2 whole cube I am going to get, and here meter cube. Centimeters has been converted into meter cube. Meter cube gets cancelled. Kg gets cancelled. Writing the formula for subjective of E, into will be equal to 128 into 25 cube into 10 to the power of minus 6 divided by 50 into 10 to the power of minus 3. This on simplifying gives equal to 40. So therefore, it is option C. Third one, it is basically, this problem is basically from the percentage of relative errors. So length will be measured of the cylinder as 12.6 with an error of plus or minus 0.1. This is diameter, and height will be measured 34.2 plus or minus 0.1. Okay, then what will be the value in volume? What is the value of the volume approximately in terms of considering significant figures? We have to work it out. So therefore, first let us go for the volume now. Volume is given by the formula, volume of cylinder is given by the formula pi r square h, but he has given diameter. So therefore, diameter r will be equal to diameter by 2. Therefore, pi square in pi into d square, d by 2 whole square, no, d square by 4 into h. This on simplifying, 3 pi is 3.14 and the diameter will be 12.6 whole square, no error here, divided by 4 into height will be 34.2. Just on working out this one, it will be giving as equal to let me put it here, it will be equal to 4262.23, will be approximately equal to 4260 only, because significant figures are 3. Here 3 significant figures, here 3 significant figures. Our answer also should contain 3 significant figures. So much is a volume we got it now. Next is next we are supposed to calculate the percentage of relative error. So therefore, from that we'll be going to find the value of the change in volume. Delta V by V is equals to pi is constant, Here you will get d, no? D square I am going to get. This is constant, this is constant. Therefore 2 into delta d by d plus power half is there into 1 into delta h by h. Therefore delta v will be equal to 2 into delta d by d plus delta h by h. This has to be multiplied by volume. Okay, 2 into error in the measurement of diameter will be, it is 0.1. 0.1. Okay, divide by original length, original diameter will be 12.6 plus of error in the measurement of height now will be 0.1 is said, divide by total height will be equal to 34.2 as mentioned, and this has to be multiplied with the volume. Earlier what we did, we have calculated the value of 42 as 4260. Therefore on simplifying, this will leads to, it is 79.7. This will be approximately equal to 80 by considering the significant figures. Therefore the volume is going to be now replaced as, volume is going to be now expressed as 4260 plus or minus 80 centimeter cube. Quite interesting problem, children. Okay, fourth one. The force of interaction between two atoms is given by the formula F is equals to alpha beta e to the power of minus exponential e to the power of minus x square by alpha kt. K is Boltzmann's constant. Now T is temperature, K is Boltzmann's constant, alpha beta are two constant. Now dimensional formula of B. Beta is asking to calculate. If you see the equation, if you want beta, definitely alpha is going to be calculated. And moreover, from the principle of homogeneity, we know that all trigonometric, logarithmic, exponential terms are dimensionally free, no dimensional constant. So therefore, since it is an exponential one, this should be dimensionally constant. X is distance, distance square, x square. Therefore, this also must be equal to that one. So therefore, in that perspective, in that view, let us write down, it is x square will be equal to alpha into k into t. K into t is energy. Therefore, alpha will be equal to x square by kt, because energy of the particle in terms of the temperature is given by 3 by 2 kt. 3 by 2 is of course constant. Therefore, kt also will consider energy. Therefore, this is L square divided by kt is energy, no? Energy means m1 L2 t power minus 2. Therefore, alpha value will be m to the power of minus 1, L to the power of 0, and t to the power of minus 2. Okay, m to the power of minus 1, L to the power of L to the power of 0, and t to the power of minus 2. Alpha. Now let us go for this one. In the given equation, f is equals to, it is alpha into beta into exponential of minus of x square into alpha kt. Since it is alpha kt, this is dimensionally free. Then f is equals to alpha into beta. I want only beta now. Beta will be equal to f by alpha. F is given as m1 L1 t power minus 2 divided by alpha value, as we have done as alpha value, it is m to the power of minus 1, L to the power of 0, t to the power of minus 2. Therefore, beta value will be equal to m to the power of 1, m to the power of divided by n to the power of minus 1 will be equal to m to the power of plus 2. 1 plus 1 will become 2. L to the power of 1 minus 0 is 1 only. T to the power of minus 2 and 0. T to the power of, this is t to the power of minus 2. On going here, t to the power of plus 2. Therefore, t to the power of plus 2. Therefore, minus 2, this will become minus 4. So therefore, m square L to the power of 1, m square L to the power of 1, t to the power of minus 4. That is your fourth option. So therefore, with these problems, we came to know that definitely students should know about the dimension formulas perfectly. Then only such problems can be worked out very easily. Okay. If speed v, acceleration a, instead of acceleration small capital, I'll use small a, right? And or we can continue, no issue, because even answer also contains even force is f are considered as fundamental units. The dimensional formula for the Young's modulus will be, first of all, Young's modulus will be, it is Stress by strain. Strain has no dimensional formula. Stress by strain. Strain has no dimensional formula. Therefore, we can go for the stress itself. Stress is force by area into delta L by L. This will get cancelled. Force is M1 L1 T power minus 2 divided by L square. So therefore, Young's modulus now will be equal to m to the power of 1, m to the power of 1, L to the power of minus 1 and T to the power of minus 2. So this is the dimensional formula of Young's modulus. That Young's modulus has to be expressed in terms of velocity, acceleration and event force. It is either the general expression y is equals to velocity to the power of a and acceleration to the power of b and force to the power of c. So Young's modulus is given by m to the power of 1, L to the power of minus 1, T to the power of minus 2. Right hand side, velocity L1 T power minus 2, T power minus 1. Just now we have used to the power of A. Acceleration, velocity by time, L to the power of minus 2 to the power of B. And force is M1 L1 T power minus 2 whole to the power of C. Okay. M to the power of 1, L to the power of minus 1 and T to the power of minus 2 will be equal to. So on the simplifying on the right hand side, only one M is there. Therefore, M to the power of C I am going to get M to the power of C. And here, let us say, if I am going to simplify for the LCM, no, L to the power of A, I'll get L to the power of A plus B plus C. L to the power of A plus B plus C. Plus C. Okay, and T to the power of right side, two terms are there. No, three terms are there. Minus A, minus 2B, minus 2C. Minus A, minus 2B, minus 2C. Okay. Now equating the terms. So therefore C must be equal to 1 and A plus B plus C will be equal to minus 1 and minus A minus 2B minus 2C will be equal to minus 2. Using the value of C here, A plus B, this is my 1. If it goes that side, I'll get minus 2. So therefore here minus A minus 2B. And here I'll get minus 2C. Minus 2 into C. C is 1. Minus 2. Minus 2 will get cancelled. I'm going to get 0. On adding, this is minus B will be equal to minus 2. Therefore, B will be equal to 2. B will be equal to 2. If B will be equal to 2, substitute here. So therefore, from the first equation, A plus B is equals to minus 2 and A is equals to minus 2. B is 2 now. Minus 2 will become minus 4. Minus 4. C value I have to find. C is 1. So therefore, your expression for the Young's modulus is y is equals to equations v to the power of a. V to the power of a. A will be equal to minus 4. And acceleration to the power of b. B will be equal to 2. And last one is force. Force to the power of c. C is equals to 1. So v to the power of minus 4, a to the power of 2, and f to the power of 1. A to the power of minus 4, a to the power of 2, f to the power of 1. Minus 4, a1. Therefore, this is your C option. This is actually minus 2. This is plus 2. Therefore, C option we can give now. Next one. This is L actually. L is coefficient of self-inductance. If coefficient of self-inductance L, R resistance, C capacitance, V potential difference respectively, then dimension formula of L by R C V he is asking to calculate. So first from the electromagnetic induction, the induced voltage V is equals to, it is minus of L into di by dt from Faraday's laws. Therefore, V will be equal to, I can write L into, it is I by T. Therefore, L is equals to minus sign, I can ignore now. L is equals to potential difference into T divided by I. I is current. Current can be expressed dimensionally as E. That we'll see. Next is here, R is resistance. Resistance is given by the formula. Let us use a Ohm's law now. V is equals to IR. Therefore, R is equals to, or small r is equals to V by I. Next is even C and Q. charge will be equal to capacitance into potential difference. So therefore, these formulas you have learned even in the 10th class also. Let us go for the substitution of these physical quantities in LRCV. L is given by VT by I. Okay. And R is given by V by I. And C V is replaced by Q. So VV will get cancelled. II gets cancelled. It is T by Q. Q by T is I. Therefore, it is 1 by I. You can write dimensionally. This value will be equal to 1 by A, or you can write A to the power of minus 1. A to the power of minus 1. That is your C option. A to the power of minus 1. Minus is not visible clearly. This minus 1. Seventh one. If SI units, in SI units, in SI, the dimensions of epsilon naught, permittivity of free space divided by the permeability of free space. In order to evaluate this one, first let us go for the Coulomb's inverse square law. Coulomb's inverse square law in electrostatics is given by F is equals to, it is 1 by 4 pi epsilon naught into Q1 Q2 by R square. I want only epsilon naught, and these two are constants. So epsilon naught will be equal to Q1 into Q2 divided by F into R square. Correct? This epsilon naught will be replacing here, and force will be replacing here. 1 by 4 pi is constant. Q1 Q2 by, it is FR square. Leave it. Next one, permeability. Force between two magnetic poles is given by mu naught by 4 pi into M1 M2 by R square. Here M1 M2 are the pole strengths. So therefore mu naught value will be equal to FR square by M1 M2. Then dimensionally, I know all these physical quantities, I can substitute very easily. Then let us go for the question. He is asking to find under root of epsilon naught by mu naught. So under root of epsilon naught is replaced by Q1 into Q2 divided by F into R square into 1 by mu naught. So therefore that formula will be reversed. You will get here now M1 M2 divided by F into R square. So therefore let us substitute now. It is under root of, because finally he want the answer in terms of MLTs only. Better will substitute. Q1 Q2 charges, no, charges cannot be written dimensionally. Charge will be given by current into time. Therefore it is A square into T square. A square into T square divided by F is M1 L1 T power minus 2. Okay, distance is L square into divide by, once again it is M1 into L1 into T power minus 2 into L square. Okay, M1 is, M is actually pole strength. Pole strength is current into length. Therefore A into L will become A square L square because of M1 M2. Now let us simplify. M1 M to the power of 1, M to the power of 1, M to the power of 2. If it goes top, M to the power of minus 2. On taking square root, you will get M to the power of minus 1. Okay, L to the power of 1, 2, 3, 4, 5, 6. Okay, this L square also gets cancelled. So similarly, L to the power of 1 plus 1, 2. So L to the power of minus 2. Minus 2 halfway, L to the power of minus 1 I am getting. I am taking square root. M to the power of minus 1, L to the power of minus 1. Okay. Next is regarding T's now. T's is here now. This is T square. This is T's to the power of plus 4. And this also T to the power of 10 to the power of 6. Therefore, T to the power of 6 divided by 2 means T to the power of 3 you are going to get. And A to the power of 2 plus 2, 4. 4 divided by 2 is 2. So M to the power of minus 1, L to the power of minus 1, M to the power of minus 1. Okay. L to the power of minus 1. Is it L to the power of minus 1 is correct? L to the power of 2. 2 will get cancelled. L square. Only 1 I'll get. Oh, one more 2 is there. 2 plus 1. 3 plus 1 4. So 4 under root will become 2, therefore minus 2 you are going to get. Right. So m to the power of minus 1, l to the power of minus 2, l to the power of minus 2, m to the power of minus 1 is here, l to the power of minus 2, m to the power of minus 1, l to the power of minus 2, t to the power of 3, and a to the power of 2, right? Therefore this is the first option. Surface tension is moment of inertia I, Planck's constant L, where taken as fundamental units. Then dimensional formula for the linear momentum will be. Dimensional formula for the linear momentum will be. Let us write down the dimensional formulas individually. Surface tension is force per unit length. Therefore, we'll get m1, L power 1, L power 1 will get 0, L to the power of 0, T to the power of minus 2. And moment of inertia I is equals to m into k square. M into k square. K is actually called radius of gyration. It's an average distance. Root means square distance from the axis of rotation. Therefore, m to the power of 1 into L square. Planck's constant, just now we did. It is Planck's constant. H is equals to m to the power of 1, L to the power of 2, T to the power of minus 2, T to the power of minus 1. Because energy divided by frequency. Energy is m1 L2, T power minus 2 divided by minus 1, T power minus 1. Next is angular moment. No, linear momentum. Linear momentum is formula P is equals to mv. So therefore m1 velocity is L1 t power minus 1. Now the dimensional formula of linear momentum I have to express in terms of SI and H. So therefore for that case let us solve it. Let us assume the equation as, let us assume the equation for the momentum as P is equals to S to the power of A dimension, I to the power of B dimension, and H to the power of C dimension. Okay. Momentum is M1 L1 T power minus 1. Okay. Surface tension M1 L0 T power minus 2. T power minus 2 whole to the power of A. And next is moment of inertia m1 L2 t to the power p, and Planck's constant m1 L1 t power minus 1 whole to the power of c. So let us simplifying and equating the powers of m here now. It is a here, b here, c here. Therefore it is a plus b plus c. A plus b plus c is equals to 1. L to the power of 0. This is 2b and 1c. Therefore 2b plus c is equals to 1. Okay, third one, minus 2a minus c, because t is not there here, will be equal to minus 1. Will be equal to minus 1. Now we have to eliminate the values. We have to find the values of ABC. So in that case, let us add third and second equation. When I'm adding third and second equation, here minus 2a minus 2b I'm going to get minus 2a minus 2b. CC will get cancelled, will be equal to 0. Therefore, which means a is equals to b. Which means a is equals to b. If a is equals to b, here also I'll put b now. A also will be replaced by b. Therefore, 2b plus c is equals to 1, and 2b plus c also will be equal to 1, which is of no use, and 2a minus c minus 2a minus c will be equal to minus 1. So therefore, even if I add these two equations also, okay, it is once again arriving the same conclusion. Okay, now minus 2a minus c will be equal to minus 1. If I replace this also will be, that will be useful for me now, because c value I can find out. C value. So therefore, here if I replace a, I'll get 2a plus c is equals to 1, and minus 2a minus c will be equal to minus 1. Adding these two gets cancel, and c, yeah, both will be gets cancelled. 2a plus 2, oh, right, fine. So therefore, it is 2a plus b. Energy, the energy should be actually m1 l2, 1 l2. If it is m1 l2, yeah, 2b plus c. So m1 l2 t power minus 2, m1 l2 m1 l2 t power minus 1 whole to the power of c. So therefore, now comparing for b, now it is 2b here, 2c here. This is 2c, 2b, 2c. So therefore, if it is 2c, this is c is b is replaced by a. We'll get 2a plus 2c. Okay. So therefore, 2c minus c will be c. C will be equal to 0. If c will be equal to 0, from the first equation, I'll be getting a plus b. C is 0, no? A plus b will be equal to 1, and c will be equal to 0. Therefore, here I'll get 2b will be equal to 1. So therefore, on subtracting LB, right? So therefore, this is minus 2b minus 1, minus 2b minus 1. Or else we can do when a and b are equal here, no? A and b are equal. Okay. A and b are equal. Let us work out clearly once again. Okay. A plus b plus c will be equal to 1, and 2b plus 2c will be equal to 1, minus 2a minus c will be equal to minus 1. Okay. Now a plus b plus c. Let us multiply with 2 on both sides. 2a plus 2b plus 2c will be equal to 2. Second equation will be 2b plus 2c will be equal to 1. If on subtracting, this will become minus, this will become minus, this will become minus. These two will get cancelled. 2a I'm going to get on the left hand side will be equal to 1. Therefore, a will be equal to 1 by 2. Right. A will be equal to 1 by 2. Next is, if I substitute here now a value from the third equation, minus of 2 into 1 by 2 minus c will be equal to minus 1. These two will get cancelled, minus 1. So minus c will be equal to minus 1, and this also minus 1 will be equal to 0. Therefore, c will be equal to 0. You see from the equation number 1, a is 1 by 2, b I don't know, c will be equal to 0. That will be equal to 1 itself. So therefore, b value will be equal to 1 minus 1 by 2 will be equal to 1 by 2. So therefore, a is equals to 1 by 2, b is equals to 1 by 2, c is equals to 0. Where c is equals to 0, therefore these two options, in which a is 1 by 2 and b 1, this is power 3 by 2, therefore b option. That is your b option. Next one. In the density measurement of a cube, the mass and edge lengths of a cube are being measured as given here. This way, the error in the measurement of density is measurement density, error in the measurement of density is asking. As we know, density is given by the formula mass by volume. Mass given by in terms of length I want, therefore I'll go for L cube of volume of length. L cube, volume of a cube. Therefore, when I go for the relative error, delta d by d will be equal to power 1 is there. Therefore, 1 into delta m by m. Though it is in the denominator, errors, relative errors will be add up. Therefore, 3 into delta L by L. Since he's asking to find out the relative error or the error in the measurement. So therefore, delta D now will become, D will be transferred here. It is delta M by M plus of 3 into delta L by L whole multiplied by D. Density also, first of all, we have to evaluate density because mass and given volume has been given. Let us first find the density. Density will be equal to mass by volume without using errors here. Mass is 10 divided by volume is 0.1 whole cube. 0.1 whole cube. 10 to the power of minus 3. You get 10 to the power of plus 4. So therefore that value I can use it here. Now, error in the measurement of density will be delta m by m plus of 3 into delta L by L whole multiplied by density. Okay, let us say substitutions here. Mass error is 0.1 and mass is 10 plus of 3 into delta L. Error in the measurement of length is meters only. Divide by length will be 0.1 meter. Okay, whole multiplied by D. D is 10 to the power of 4. This on simplifying, gives it is 0.31 into 10 to the power of 4 will be equal to 31 into 10 to the 3100 kg per meter cube. I think all the options are different here. It has to be 10 to the power of 3. This has to be multiplied by 10 to the power of 3. Big mistake, right? 10th one. The area of a square is this one. Area of 7 such squares he's asking to calculate. Based on this problem is based on the significant figures. So therefore A dash total area will be equal to 7 into area of the each one. 7 into area of the each plate now will be equal to, it is 5.29. On multiplying, I'll be getting the value as 37.03. 37.03 is the one I am going to get now. But actually here, the given answer contains only 3 significant figures. The given initially, the given area contains 3 significant figures. Here, this also should contain 3 significance. Hence, on rounding off, this can be written as 37.0. If I write only 37, significant figures will be 2 only. It will be once again violating the rule. That's why I have to go for 37.0 centimeters square. So it's quite simple one. The formula for x is equals to 5yz square, where x and z are dimensions of capacitance and magnetic field, and what are the dimensions of y? Y we are supposed to calculate. So taking the given equation, x is equals to 5 y z square. Here phi is constant, therefore no need to worry about this one. Therefore, writing the formula for subjective phi, ignore phi. Writing the formula for subjective of y, don't use this phi now. So therefore, y will be equal to, it is x by z square. X is by definition, x is, where is x now? X has a dimensions of capacitance. Z has a capacitance, Z has a units of magnetic field. Therefore, X will be replaced by C, Z will be replaced by B. Okay, C is equals to capacitance, work done per unit charge. C is equals to work done per unit charge. And the magnetic field E, C is capacitance. C is capacitance. Capacitance will be equal to, no, capacitance can be now replaced by, just one second. Let us use a formula for the capacitance using the charge. Since Q is equals to CV, C will be replaced by Q by V is potential, and B is force per unit magnetic pole strength. Okay, this will be equal to Q into magnetic pole strength divided by potential is work done per unit charge. Charge will go top. into force F. So therefore this value will be, it is Q square. Q is current by time. Q is current by time. Okay. Current into time. Q is equals to current into time. And this is, and final answers also in terms of current only. Okay. Q will be equal to, Q by T is I. I is equals to QT. Therefore, Q square will be equal to I square into T square. Magnetic pole strength. This we can use even A also. Okay, A also. And magnetic pole strength is current into length divided by work done. M1 L1 T power minus 2. M1 L2 T power minus 2. Okay, this one is F is M1 L1 T power minus 2. So therefore, on further simplifying here itself, it is m to the power of minus 2. Work is M1 L1 T power minus 2. And this is force is M1. So therefore, m to the power of minus 2 I am going to get. Capacitance C is equals to Q by V. V is equals to W by Q. Q square. Q square will be equal to A square T square. Okay, right. Here work. Work is M1. And force. So this is F square. This is Z square. No? Z square it should be. Z square means B square. You'll get even. Okay, this we have represented here. Q is equals, C is equals to Q by V, and this is B square. C by B square. B square will be equal to F square by M square. Even this also will be squared. This also will be squared. This also will be squared. Square, square, and into the power of 4 will get. So m to the power of 2 plus 1 will become minus 3, and L to the power of 4. And here L square is there. So therefore this L square will get cancelled. Only L to the power of minus 2 will get. L to the power of minus 2. And T to the power of, if I see, T to the power of minus 2 plus 4 will become T to the power of 8. And current to the power of here 2 plus 2 will become 4. So therefore m to the power of minus 3. There is m to the power of minus 3, L to the power of minus 2, T to the power of 8, and A to the power of 4. So therefore actually this B option is correct. Thank you, children. We'll stop here.